Okay, hi, welcome. This is a very long-waited, anticipated, and very past due video that should have been done weeks and weeks ago. I cry your pardon. Um, I'm a lousy person. That's all there is to it. What I'm going to do for you is I am going to model the exam 1 for the spring semester 2018. This exam had, get you out of the way, 3 parts to model. We begin with part number 1 was a bottle, part number 2 was a fastener, and part number 3 was a clamp. So I will do each one the way that I would model them. You know, it's just, if you didn't do it the way I did it, that's fine. I know there are more ways than one to create these models in SolidWorks. Just you know, my 15 years experience with SolidWorks, I've found to be the easiest way to do things. So anyway, so we got a bottle here. The sketch will be off the screen so that it's not interfering with the SolidWorks as I'm modeling. Just so you can see it. Okay, so we have a 6-sided bottle that is 50 millimeters across the flats, has a 20 millimeter OD on the neck of the bottle, a 2 millimeter thickness of glass, and then these various heights with a radius in here and a 5 mil radius on each of the corners past the hex. So how would I do this? This is how I would do this. I would start by making a part, and I am using the student version of SolidWorks 2017-2018 because that's what I have on my laptop at home. So we start with a new part. So first thing I'm going to do is build all my reference planes. I'm going to put the top as the bottom of my bottle, and then I need a plane that is oh, we probably ought to change over to millimetrics, make it a lot easier for us. But for right now, we can just specify that this one is 70 millimetrics up and accept that one, and then we'll come down over here and change everything to millimetrics, grams, and seconds. Then we don't have to use the to convert from inch to millimetrics. So we got our first one. Then our second plane, reference plane, is at 105 millimetrics, millimeters, sorry. And then the last one is and what I'm doing here is I'm selecting the top plane, control button, left mouse, and dragging up, in case you are unaware of how I did that. Another method to do these would be to select on the plane you want, come up here to feature, and go to this and go to plane, and then tell it the offset that you want. I'm lazy. I find it a lot easier. Just grab that left mouse and drag, and then you can specify if they're parallel planes. If you're doing one that's at an angle to the plane or at a certain angle, you know, I mean, you can make a plane in any orientation in space that you want. I'm going to turn this one on just to drive me nuts, but we're going to do it anyway. So for the base up to the first plane, we have the hexagon shape. So we're going to do a sketch, and I'm going to pick my polynomials here, or polygons, and we are at 6 sides. So if I click in the center, come down here, and it doesn't matter where we put it. However, I do like to have all my sketches fully defined, and right now rotation is allowed, so we're going to grab that guy and make him horizontal so we can no longer rotate. Now we just got ins and outs, and then we will select a dimension, come over here, and that is 50 millimeters, and call it good. Now this guy here is pretty much straight up, so we don't need to do a loft on him. So we're going to come over here to our features, and we're going to take him up 70 millimeters. Okay, yeah, we probably doing that would not have needed this plane here, but we got it anyway. You know what, we're going to delete this guy. I don't want him anymore. See, I'm deleting that because if I put the sketch on this plane rather than on, or not this plane, on the surface rather than the plane, if I change this dimension, it will change with it. If I leave it on that plane, then it creates all kinds of craziness. Okay, so from there up we go from a six-sided surface to a round surface. So we're going to pick this guy here and do a sketch, and we want a circle right here in the middle, and our circle is 20 millimeters. Sorry, millimetrics is a habit to say. And we just want to sketch there. Okay, and then we also want a sketch here, so we're just going to grab that surface, do a sketch, and I'm just going to extract convert the entities, which just grabs all of the exterior surfaces of that, or edges of that surface, and turns them into a sketch. And then we will take our front plane and do a sketch there. This will be our guide sketch, and I'm not sure exactly where that guy is, but we'll just for now put it there and there. He needs to be black too. Okay, so we can see that this guy's black, which means he snapped right to that corner. This guy up here didn't. He's red or blue, so see, he can still move. So if we grab that guy and this guy right here and tell him to pierce, that line's black now, which means if you make changes to this, it will also change that line. That's why I like having all of my sketches fully defined. So now we can come to the loft command, loft, and our sketches, we're going from, you can either select the sketches here in your field, or you can come over here and select them here too, whichever way is more easier for you. And then our guide will be sketch 4. It probably really doesn't need it because it's a straightforward. Oh, wait a minute, we left something out, and see here, this is what should be good. We forgot on the radiuses on the corners. Now you can do those radiuses two ways. You can do a separate separate feature of radiuses. We come down here and put fillets, do 5 millimeters, and select all these surfaces. Not that surface, this surface, this surface, and this surface. Okay, and that gives us our 5 millimeters. Or if you want to minimize the amount of stuff you have over here, we can go back to our sketch and pick a radius of 5 millimeters and pick on each of the dots here. And this is going to make it scream when we're done because there's no surface for that fillet we just put in to radius 2. We're just going to ignore that, and it's screaming because of this fillet right here. So we're going to get rid of that, close, and see, we got a problem now with our sketch here because we took away the corner that it snapped to. So we will go on here, right mouse click, go up to edit sketch, and we will grab this guy right here and click on that mate and delete it, and then take and do like we did above, grab that surface, that point, and tell them to pierce, and then everybody is now happy. Happy, happy, happy. Okay, so now we've got this guy here. We can we want to add the neck into it next. We can do that a few ways. Let's do it this way here. Let's grab this sketch plane, and we want to do an extrusion, and we're going to do a circle. Now there's a couple of ways to do this. If you want to tie that to your existing circle, you can grab that guy and this guy right here and make them co-radial. That way if you change the lower one, the upper one will change with it. Or you can dimension it and make the dimensions equal through some oh, what is that? Equations. You can add an equation to where those will be the same. We'll just make those two collinear or co-radial, and if you clicked on it, you'll look down here and you'll see that it is a diameter of 20 millimeters, so that it is the proper size. And we're going to exit the sketch, and we're going to extrude up to a surface, up to this one right here, which is that surface down there, and call that good. And now if we make any changes, everything will change and everybody will be happy. Okay, so now we need to add a 15 millimeter radius right here, so we'll click on that surface, go to fillet, do 15 millimeters, and call it good. And so there's the outside of our bottle. I don't like these things. That's hard to see apart when they're hidden behind a whole bunch of planes, so I always hide them. Now the last thing we want to do is select on this surface here, go to shell, and we want to have a 2 millimeter wall. If you want to show the preview, you select it and you'll see that that shells out the whole bottle. And if you want to see, make sure it goes all the way down, you can see right there that you've selected the bottom of it. So that is how I did the bottle. You know, if you have any questions on these, by all means, let me know. We'll do a save here. Not create new. How about we save? Save. And I'm going to save that to my SolidWorks file. Somewhere I have a SolidWorks file. I don't have a SolidWorks file. Oh, well, let's create a SolidWorks file. Oh, don't do that. Now where'd my SolidWorks file go? Refresh. Go back into... there you are. Hey, I did have a SolidWorks file. There we go. Cool. I thought I had one. And this would be a bottle. And I'm just going to put a spring 2018 on there so I know when it was created. So there's the bottle. Okay, so next up in the exam was a fastener. This is real simple design. Should be able to do that in two features. We'll do a revolve and then we'll do a cut for the slot. So we're going to do a part. This time we're going to do on the front. We're going to create our oh, we're going to tell it what we're going to do first. Okay, so we're doing a revolve. We need to do our center line, so we're going to pull the center line off of here, and then hitting the S key brings up this menu. Yeah, and so we're going to draw solid lines now, and I'm just going to sketch out the fastener. You got to do half of it. Okay, and then we'll come in and dimension. If we click on the center line, we can then dimension all of our radii. This had a diameter of 5.75 millimeters. This had a dimension of 12 millimeters. This had a dimension of 4 millimeters. Our overall length was 20 millimeters. Why aren't my... oh, because my something here's not... oh, that didn't attach to the origin. There we go. We'll take those two and make them coincident, so all my lines should be turning black. And then we got to do a 30-degree angle on the tip. So from there to there, if we have 30 left over, that means this is 60. Okay, and we have radiuses on the head, so let's do those in here of 1.250 on a radius here and a radius there, and click OK. We're done. Oh wait a minute, you didn't finish the radius, so let's go back to add our edit, and I should still have the right. Hit that, and then say yes, and then close that. Okay, so there's the body of the, and if we click on this, this should be 5.75. Click on this one, should be 12. If we click that surface and control select that point, okay, it's not going to give it to us. So if we'll come up here and go get our toolbox, put it up here and measure, we'll see that the dimension is, normal distance is 20 inches. Oh, I'm in inches again. Hey, cool, you guys should have said something. See, yeah. So if you did the same thing on the exam, I don't think I docked you for it, because yeah, but this should all be, so let's change that to millimeters now, and now let's see how bad we are. Oh yeah, that's 300. Okay, so let's start by changing. Are you really going to post that on Facebook that you're so stupid you did it in the wrong units? Yes, I am. So this here was supposed to be 5.75 millimetrics. This one was supposed to be 12. This one was supposed to be 20. I didn't want a minus 20. I want 20. And this one was supposed to be 4. And the radiuses were supposed to be 1.25. And now if we redo everything, where'd my redo button go? Somebody stole my redo button. How can I not have a redo button? Oh, it's right there. It's not letting me do it. Oh, because it thinks I'm still changing a dimension. There we go. And now everything's a lot smaller, but it's still the same. That's 12 millimeters, and again, let's pull up our measure tape and measure from there to that tip, and we're 20 millimeters, and from there to there is 4 millimeters, and they're parallel. Okay, so the last thing we need to do to this guy is put the slot in. So we'll grab the front plane, come to our features, and do a cut, not a revolve cut, we just want to do an extruded cut, and we'll put a square there, and then you can dimension that so that it is centered in there, but I like to take a construction line from the origin to the center of that one and then make this guy horizontal, and now I know it's symmetric, so no matter where I move it, it'll always be symmetric. So it is down dimension 1.5 millimetrics, and it is 2 millimetrics wide, and we're done. We're going to extrude cut blind through both all, and there's our fastener. Pretty simple little part, especially if you remember to put it in the right units. We'll try and do that one on the last one, do it right. So let's save this one. We will do fastener spring 18. What do you mean it's not a valid name? Oh, you did open because you're stupid. We want to save, you dummy. Okay, so there's our fastener. So the last one we have to do here is this clamp. This is a straightforward. We can do this in 3 moves. So let's do it. So we get us a new part, and the first thing we're going to do this time is change over to millimeters. Yeah, okay, so we're going to start with the front, and we're going to extrude, and we're going to do the side of the block first. So we're going to put this corner down here, and we're going to come up, over, down, over, down, down. Okay, you'll notice that this line's not parallel, so we'll just grab all those lines. We want to make them all horizontal. And now we will dimension. So this here is supposed to be 25. This is supposed to be 55. This is supposed to be what's left over. So we'll delete that. The dimension given in the drawing is this one, which is 95 millimeters. And this one here is 125 millimeters. Okay, and I like to keep my parts centered about the origin, going back and forth this way. So we will do our extrude, but we're going to do a mid-plane blind, and that'll extrude it both. Can you see my hands making the movement there? Yeah, I'm sure you can. It'll extrude the part both directions equally about the sketch plane. And we are 40 millimeters, so if we go 40, so that means each side will be 20. I like to do that for when I get into mating. If I want to mate something to the center of that block, I can mate it right to that plane. And I don't have to create planes. I don't have to create geometries. I don't have to create things, or or do an offset. I like symmetry. Okay, so now we got two more things to do. We got to put a hole in it. So let's put a hole in it. We'll grab that surface, do a cut, do a circle. That circle's too big. Yes, I know. We'll bring it down a little bit. Okay, so it's on center. So we'll grab that and put that there. And grab our tool here. The hole is 20 millimeters, and it is, oh, look at that. We can just dimension that line because that's what's given, and then we'll do a cut through all. And there's our hole. And then the last thing we got to do is a little slot on top. So we'll collect this surface here, do an extruded cut, bring it orthogonal, parallel to the screen so we can see what we're doing. And so it looks like it's just a simple box with two radii. So we'll grab that corner, go there, there. We'll put our radii in, which are 3 millimeters. Okay. And then again, to keep it centered, I'll grab the center of that line, bring it down to the center point of that one, and then make it vertical. And now you'll see it moves the same, and that'll give us our 7.5 typical there. But if we do a dimension here of 25 and a dimension here of 12, tell it to cut through all, and that's it. And we'll save this block. This is a clamp from spring 2018. And so there, I know I went through those pretty quick. If you need to rewind and watch over, that's fine. If you got questions, by all means, send me an email or chat or something. Okay, thanks. Bye-bye.